Welcome to Jaka Context. Now in this tutorial I'll be putting us through how to measure a raft foundation. Right, as you can see on my screen now, right, this is a typical raft foundation. A foundation can either be strip, pad, raft, or pile. It could be strip, it could be pad, it could be raft, it could be pile. We have discussed pile foundation in one of our previous tutorials. Alright, kindly check out on the Jaka Context YouTube channel to assess that particular video and update your knowledge. Now in this video we'll be talking about a raft foundation. A raft foundation is basically a type of foundation that consists of a thick solid slab of concrete that covers the entire footprint of a building, of course with good ground beams underneath it. Right, you just see it's a concrete slab all through, right, but there are ground beams underneath it, like what we have here. As you can see here, this is GBM1, this is ground beam 1, ground beam 2. You see here, these are beams. Right, now over it you're going to have a concrete slab, usually a thick concrete slab, reinforced concrete slab will come over it, and then you have your structures. They are mostly used areas where you have poor soil, where you have soils with low bearing capacity. Right, most times that's where you use them. Maybe in sandy soil you get, and these are major places where you use them, and also where you need to carry high loads. They're also good for load bearing structures. They say maybe 1 story, 2 story, and all. The raft foundation is very good. Now this is basically what you see, and now this is it. Right, now these are the ground beams. As you can see, these are ground beams. Now these reinforcements you're seeing, there are areas where you're going to have columns in superstructure, but in the substructure you won't see these columns because they are already cast together with the ground beams. All right, so these are reinforcements. These reinforcements are going up, indicating that okay, at this point you have columns. So the reinforcement from the column in the superstructure will come and connect with this, and then continue the run to whatever floor you want to. Right, and of course when it is filled, right, what we'll have here, this is going to be filled. These places are going to be filled, and this is what you're seeing here. After they are being filled, you fill them, and then you compact, of course, then you blind, and then you place your reinforcement, and then you cast. All right, and DPM, damp-proof membrane, you blind, you damp-proof membrane, you place your reinforcement, and then you cast. All right, and this is another I couldn't get the section for this. This is 6 meter by 6 meter, but this is another raft foundation design. All right, this is 6 meter in 6 meter by 4 6 by 4 meter panels. Right, while these we have different values to play with, right, at the various edges. And we have a section, of course this is a reference to NIQS, test of professional competence examination. This is drawing number NIQS Lagos MRC TPC 2019 mock exam for 2019. So I was able to lay my hand on this page, right, on this sheet. All right, now let's look at it. If you look at this particular section here, this section shows the ground beam. This is the section of the ground beam. Right, this is the slab. We're told that the beam is 300. The beam is 300. You can see the slab, the connection between the beam and the slab. The beam we're told is 300, while the slab is 200 thick, and a blinding of 50, and a blinding of 50 right? You see the depth of the beam that is not in the slab. No, the blinding is 900. You can see the blinding here below the beam is 50. There are two blindings. Let's say I see blinding here and blinding here. There's a blinding before the reinforced concrete slab, and there's a blinding below the beam. So this is a typical section. These are the respective reinforcement. You have 3y20, you have 3 by 2 by y12. These are the main bars, these are the runners. These are the stirrups. These are also main bars. 3y16, 02, 02, 01. This 01, 02, 03 are bar marks. I've discussed this in one of our previous tutorials also. Okay, this section describes the ground level, so that when you want to fill, you know the depth you're filling from when you want to fill. In this case here now, this is the ground level. This is, see my color, you see this sand is the ground level for this, right? Now this is what they are going to fill. Here we are being told this is the ground level. From the top of the slab, it is 600 from the top. So what I'm going to fill, if you see my cursor, this is already the slab. There's a blinding here, right? This is what we are filling. This is what we are filling. If you see my cursor here, all these places below, they are natural ground. They are ground, right? Natural ground. So just from here to here up is what we are going to fill. All right, let's quickly jump into it. Now this is basically what having studied the drawing. Let's see how we measure them. Of course, this is your taking off sheet, and this is a Raft foundation, like we rightly said. This is the drawing description. This is the reference BSMM. Now these are takeoff list. Of course, when you're taking off power foundation, you say at least they're going to be site clearance. You're going to clear the site. You're going to prepare the site. Topsoil removal. There maybe you deposit in temporary spoil heap, or you are taking away out of site, whichever one you want to do. And also you have to import filling. That's this filling I showed us. You have to fill. And then you have to put your damp proof membrane. Of course, after blinding, your damp proof membrane. Oh, which one even comes first? Oh, okay, your damp proof membrane, and then you blind. Your damp proof membrane, and then you blind, and then the reinforcement comes. Okay, yes, so that the reinforcement does not puncture the damp proof membrane. So you damp proof membrane, then you blind, and then your reinforcement comes on it, and then you have your concrete work, and then your reinforcement work, and then your form work. All right. Okay. These are columns. We have columns. This is C1, and we also have column C2. Let's call that one 300 by 230 All right. Let's say this is C1. We have C1 and C2. I'm just doing that because we're not given here, because the drawing is not to scale. This drawing is not to scale, as you can see here. Right, it's a sketch. So just okay, the bigger ones are 300 by 230, while the smaller ones are 230 by 230. It's an assumption, and now you assume basically where you don't have made more details like what we have here, and also where you're writing an exam. If you're writing an exam, any exam, and you want to start from the foundation, you need to make some of these assumptions. Okay, telling your examiner that okay, you assume that uh, there is no the water table is low, meaning that you don't have to provide for removal of underground or surface water, and also that there are no services either underground or below, like electrical services above, or maybe a gas pipeline, oil pipeline going underneath. These are just assumptions. Now, all you, if because of the for an exam sake, you're only trying to tell your examiner that okay, oh, I know these things, so I'm assuming that they are not there, right? It gives you more mark. It gives you more mark if you're writing an exam. All right. Okay. Then we're not told about the reinforcement projection, and the drawing did not show any reinforcement projection, right? So if I say I assume it to be 1 meter, great. And if I say it is not there, great, because the drawing did not show it, right? I hope we can see. Of course, there's this beam here where you have all this intersection here. Reinforcement is going to come out. This is what I showed us here. See, reinforcement is going to come out. It's going to come out, right? They are going to come out. That is what you call projection. But our reference drawing here did not show it. So I can, if in an exam situation, I can assume that, and I can also not, because the drawing did not show it. All right. So whatever assumptions you can, if for an exam, whatever assumption you can just think, you can put them there. All right. And also, we're not told the thickness of the blinding, but of course we'll say okay, the blinding is 50. Blinding is 50 mm most times, generally, but blinding can also be 100 mm. All right. Let's say blinding is 50 mm. Blinding is there. We're told though. Is in the drawing now. Am I right? Yes. No. Blinding is there. All right. Let's go ahead. So, having done my takeoff list, your takeoff list is very important. Like I said earlier, I've stressed it over and over again. Do a takeoff list for an exam. If you didn't finish, your examiner knows. He knows what he wants to do, but there wasn't time enough to finish. Right? Okay. So, and also if you're working with that for in your office or for a superior, you need to prepare a takeoff list. Takeoff list guides you. It helps you to ensure you don't miss anything when you're doing your takeoff. All right. Now, excavation and filling. Of course, we need to clear the site, right? Because we are doing from the foundation. We need to clear the site. We need to remove topsoil. So, site clearance. This is my waste calculation. This is my waste calculation. Again, if you're writing an exam, the NIQS exam, this your waste calculation will be on the right hand side. Kunjiko. If you're writing an exam, there's the NIQS exam, your waste calculation will be on the right hand side. I'm working with Excel. Right? I'm working with Excel. Okay, now this is what I mean. If I say bam, you see, these are to be on the right hand side. My waste calculation. If I am working for an exam, in an exam, of course you'll be told in your MRC that waste calculation is on the right hand, just on the right hand side of your paper. But most times, depending on the size of your paper, it doesn't mean if it's in the middle you are wrong. If your paper is wide enough, right, to accommodate what you want to do, it should be on the right hand side. All right. It doesn't mean if it is here, they will score you 0. No. Nobody will score you 0. All right. But just take note. It should be on the where you have enough space to work. But and if not, like if you don't have, do your waste calculation first, and then your description, and then you enter into your dimension column. All right. I hope you get it. All right, let's go. Now, of course, if your site clearance is a square meter item, it covers the entire length and the entire width of the site. Complete length times width. All I need to do is add up this, If you see this dimension, it is center to center. So I need to come out because I'm doing site clearance. I need to come out, and we are told that the beam is 300. Now if this beam is 300, this column cannot be 300, cannot be 230. This column be, the column be 300 by 300, where we said something here. This column will be 300 by 300, right? And this will be 400. Let's call this 3. It's an assumption anyway. By 300. But because since the beam is 300 by 300, there's no way we'll have a 230 column inside, right? Except the beam is 230. All right. Okay. So total entire length, I just added everything up. This is 4525, and I added 3 times 2, 3 by 3825. That means 3825 times 3. And then I take this plus this plus this, then I add half and I add half. That's what you see here. Add 2 by half by 300, add 2 by 300. So I have 16300 by 8935. That's what you have here, 16.3 by 8.94. This is site clearance. Clear site of vegetation, your BESMM 4R. You can see the reference there. It is a square meter item. I don't know why this guy is a superscript. It shouldn't be a superscript. Right, so it is a square meter item. Now you see and now what this means is this: I can use this dimension for other works that are also square meter item. They are also square meter item. Take for instance, this is site clearance. Topsoil is also a square meter item. Removal of topsoil is a square meter item. Right, now instead of me trying to do this one again, 16.30 by 8.94, right, which is normal, right? I just say and means I'm using the description above, I'm using the dimension above for this second item also. That is what and means. And is a connector, right? I'm using this same dimension for this description. Now, if I do it like this, am I wrong? No. Kunjiko, you're not wrong. Especially if it's an exam. You're only telling your examiner, I understand principles of taking off. I understand principles of taking off. That is what you're only telling your examiner. So if somebody does it like this, the person is right. You are going to score the same mark. Maybe bonus for using this. Maybe half mark bonus or 1 mark bonus. You get? Or it just tells your examiner or your superior or your boss that okay, this person has an idea of principles of taking off. All right, I hope that helps. Okay, we go ahead quickly now, and also we want to retain. It's either we can retain or we can remove out of sight when they are not useful, especially when they don't have a good bearing capacity. We can take away out of sight, but if we want to reuse them, we retain them. We use another and, but in this case in a different way, because if you want to retain now, you want to store in temporary spoil heap, it's a cubic meter item. Now this is how you do it. One, you can say and I'm maintaining this, but here I multiply by 0.15. Remember when we're doing reinforcement, we say reinforcement is in tons. We do something like this: multiply by the weight divided by 1000 to give us in tons. Remember that, right? Okay, that can also, but in this case now this is a cubic meter item. That's why you multiply by 0.15, maintaining this dimension. If somebody had done this 16.3 by 8.94 by 0.15, would the person have been wrong? No, the person wouldn't have been wrong. right? But we are trying to maintain this dimension for this item, right? So that's what we're trying to use, and the principle of and in connecting various items by maintaining just one dimension. All right. Okay, please take note. When you don't understand, say, okay, how use do it the normal way. You are going to have your answer correct. Now, if I do this, this is not going to be there. This 0.15 will not be there. Otherwise, you are saying something different. I hope you get that clear, because we already did it here 0.15. All right, let's take note of that. So we continue now. After having done that, having cleared the site, having removed topsoil, having retained topsoil in temporary spoil heap, then you have to excavate the ground beams themselves. These guys also, the ground beams, the ground beams. All right. Okay, now this is what we have here. Of course, we have this 1, 2, 3, 4, and then we have this 1, 2, 3, 4, 5. Excuse me. All right. Okay. So this is, of course, we already did this before. This is 16,300. You remember? All right. I just multiplied by 4. 1, 2, 3, 4. That is why you see here 16,300 by 4 gives me 65,200. And then here also you see 8,935. I list 4 by 300. Let's see. Okay, because I already came out. You remember we already came out to the outside when we were doing site clearance. So I'll bring in 200, 300, 300. Let's 2 by 300. This will give me 600 as I'm coming in. Now remember, in this excavation you don't consider working space. A workspace. There is no workspace. The BSM4 does not account for workspace. Workspace is allowed for in your rate. That's why I say I didn't put workspace. Why is there no workspace? That is the rule now in the BESMM 4R. Let's say this is 600. Now this is 8335, right? So that this gives us 8338. This is 8335. All right. Okay. Now, of course, if you come here, someone might say, but they see there are intersections here. Now, because I have done this, now I want to do this one. Okay, let me see. Am I there yet? Have I? Okay, I have not entered. Okay, but I want to, let me just explain that. Now we have this. We have taken 1, 2, 3, 4. Now I want to take 1, 2. Where are you? 1, 2, 3, 4, 5. We've done the horizontal. We want to do the vertical now. 1, 2, 3, 4, 5. All right. Okay, let's go ahead first. Now the depth of the excavation we want to do for the beams. All right. Now this is the total depth. We're told that the slab is 200. We're told that the blinding is 50. I'm just trying to bring out what is here. See them here. Right. Slab is 200, blinding is 50. The beam is, according to the section, 900. Then the blinding to the beam is 50. Everything here is 1,200. Now there's an above. We're told that there's an above ground. Let's 600. Let's see. We have 200. We have 50, because the blinding is on the. We have 50. We have 50. Okay, okay, okay. Here, okay, this is the part of the beam that is below the ground, right? Which is what we are doing excavation. This part is above the ground. So remove 600 from everything we have here. We'll be having another six, but it is 1,200, which is what we have here. That's why you see here less 600. That gives us 600. So the depth of our beam, ground from these details we have here, is 600. It is 600. All right. Okay. So of course, this is your description. Excavation commencing 150 mm below ground level. We already, this is going to change 106,875 because I did an adjustment there. 106.88. All right. So this is what we have. Now, if you come here and see there are these are okay, I'll explain it. These are their intersections here. Now I did this because I already less this one to come out. I have this, I have this, I have this, I have this. All right. Now we say, but we've done this, right? That means we've done this. Since we took it down here, this also, and this also, and this also, which simply means that you're going to be having intersections. Now these things are they are minute. Most times you just take them straight and you overlook those intersections because the quantities are always very low. But if it's an exam and you want to show your examiner that you know what you're doing, now this is already out, this is already out, right? So we have these guys here because I've already taken to this point, I've taken to this point, and taken to this according to what I did here because I multiplied by 4. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 intersections. 2 of them is C2. No, they are the same thing. 300 by 300. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Less intersection. This is by 10. That's why I say I put it in red. Let's say we are less in intersection. Right. But most times, now let's see. This is 0.23 times 0. They are 300. It's not. The beam size is 300. The beam size is 300. Right. 0.3 times 0.3 times 10 is 0.9, 1 cubic meter, right? And of course you know how much 1 cubic meter is. So basically this is what we have. Right, now this is the excavation, right? And also what I excavate, I dispose, because what you're excavating is where you have your ground beam, right? So that you have to dispose. So and dispose and dispose. That's why you see I'm using this now for this also, right? That could be because this is small. That's why most times you see we just go straight. You say this multiplied by this, it is not going to affect it significantly at all. So most times it is this multiplied by 1, 2, 3, 4, and this multiplied by 1, 2, 3, 4, 5. Right, but you want to show your examiner that okay, you understand this, no, okay, this place the intersection, so let me remove the intersection so that I don't double measure at those points. But majority of the times it is not necessary. Alright, so and disposal, because this is what I excavate here is what I am still going to dispose. Alright, that's why you see here I'm using this same dimension to cover for this other item also. All right, having done the excavation, we want to do okay, the filling part. Okay, now of course this is what we have here. I already showed us this before. This is what we have here. This is what we want to fill, and this is what we want to achieve. All right, I want to fill into in. It is what we have here. Imported filling. Well, this is the depth above ground. Is 600. This is it here. This is the depth above ground. So we remove the topsoil. I'm on the topsoil. Remove the reinforced concrete slab, and then we are going to remove the blinding. This is less floor bed, less blinding. So my filling depth is 350. I am filling in to in. I must come in here because every of my filling is in to in, which is what we have here. So I distributed them into panel A, panel B to D, panel E. This is 4525, 3225. I want to come inside because I was already outside. Now according to this is center to center. So 4525 less 2 by half by 300, that's less 150, less 150. I'll come here. Here also less 150 here. I'll less 150 here. I'm here. Alright, so this is basically what we have here. The same thing goes for every of the other panel. That is why you see here panel A, panel B to D, panel E, panel F to H, panel J. I have to come in to to achieve that. Then panel K, L, M. Now the concrete work. Of course, we have concrete work in the beam. This is 106.88. We have concrete work in beams, and then concrete work in the slab. Right, we already know the length of the beam. We know the width of the beam. Okay, this is blinding first because there's blinding first, then before the beam. All right, this is the total length. This is the total width of the beam. This is the thickness of the blinding, 50 mm. Right, so this is the description and the reference in the BESMM. For if you're writing an exam, you must put reference, you must put unit. It is very, very important. And now the reinforced concrete, the same thing, the same length, the same width, but a different depth. Right, 0.95. This is 900. Less blinding, and I got 950. Length is 900. Depth of beam. Okay, let's come here. Okay. Okay, this is the depth of the beam. How does the blinding come? So this is it. Alright. We have the length of the beam, and then this is it here. This is the length of the beam. This is the beam. Right, this is the length of the beam. This is 900. Right, we're measuring for the beam now. This is 900. This is the blinding, which is 50. Now let's see what we have here. Let me explain it from here. You can see this reinforcement here is exposed, so that the one coming from the slab can also connect with it, right, with these beams. Very, very important. Right, so if you see here, you see the blinding, you see this reinforcement, you see the beam here. The beam is above, right, because the reinforcement is going to come to connect. So the total beam is 950. 900 plus 50. So that's why you see here 0.95. Now for the ground floor slab, we know the slab is length times breadth, and then thickness complete. Length times breadth and thickness, which is basically what we have here, 16.3 by 8.9 16.3, 8.93. We are told that it is 200. 8.93, 8.93. Yes, now I'm going out. 8.94. This is not 8.93. This is 8.94 because we already calculated. Excuse me. 8.94. So this is what we have for the beam. Now for the concrete rather, excuse me. I have code. Now the reinforcement. The reinforcement, the drawing didn't give details of reinforcement. Right now, if it's an exam, what they do is they use factor. They say use the factor of maybe 80 kg per cubic meter, or 90 kg per meter, or 70 kg per cubic meter, or 120 kg per cubic meter. Right? As you can see, there's no reinforcement detail apart from what we have here in this beam. For the slab, you don't have anything. Okay, now let's work out something. Now reinforcement, this is total beam. This is 106. 106. Right. So we want to calculate the reinforcement of the beam since we know the total length. This adjustment I made now. 106. Alright, okay. Okay, so this is basically what we have. They want the total length to be 106. We remove cover, of course. We'll be discussing that if you want to see the reinforcement, you have to remove cover 50 mm. That's 2 by half by 2 by 25. Rather, that gives you 50. Now, in the placement of reinforcement, you know the length is very long. Now we want to take it once because we don't have a breakdown detail. The length is very long, 106 meters. Now, of course, normally you're going to be having laps. So you need to account, because the length is very long, you need to account for them in your measurement. Now, a reinforcement is normally supposed to be 12 meters, but they don't come in 12 meters, they come maybe 12.7, some even 12.5. So the total length 106 divided by the length of one reinforcement, which is 11.7. I'll get the total laps to be 9. Right, I get total laps to be 9. Then add bent 300. That's 150. 2 by add bent 2 by 150. 2 by 150, which is equal to 300. Right, add bent. Okay, this is this. That's the lap. We are 1 meter. Okay, add overlap, which is 1 meter. So I have 9 of them. The right side is 9,000, and then we add bent, which is 2 by 150, which is 300. I have a total of 116. 116.13. This is what we have. Now, reinforcement is in tons. If I leave it like this, I only calculated in meters. Right, this is 2.47 because we are told this is Y20. Let me take us back to the drawing. See, this is 3Y20. These are the main bars. See another one here, 3Y16. Right, these are the main bars. Now, that's what you see here. High reinforcement steel bar to BSDs, 10 to 16 mm diameter, straight and bent, because they are bent. 3Y20 01 main bars. All right, that's what we have here. There are 3 in numbers. The same thing. This is another main bar also. This is 116. There are also 3 numbers. See it here. 3Y. That's why I actually use this, because it is dynamic. It is not a straightforward thing. 3Y1602. That's for the bottom bars. Right? This is what we have. 3Y1602. Then we have the distribution bars, or the runners. These are them. These are, if you see the beam, There's the one on top, there'll be one on the bottom, and then you have the one that are running by the side. That's what you call the runners or the distribution bars. Okay, which are these? We are told that it is 3 by 2 by y12, right? 3 by 2 by y12. So this is the length they run. 112.88. Is there a waste calculation for that? Okay, yes. Okay, this is what we have. No, this is 106. We already adjusted that. This is 106. This is also 106. We already adjusted that. All right, so this is 115.88. All right, so this is the length, and then we add the lap and then everything we did here. All right, so this is basically what we have here. It is 12 mm, so 0.888 is the weight factor for weight in kg per meter for 12 mm. So of course we need to add the links. That's the links, the stirrup, tying them. We need to calculate for them also. So this is it is what's it? The beam. Excuse me. Depth is the beam depth is 1150, right? Which is what we have here. This is 900. This is 50, and this is 200. 900 plus 200 is 11 plus 50 is 1150. That's what you see here. Then we let's cover, and then we add bent. Right, so let's cover, add bent. That gives me 3000. Right, so the number of links we are going to have, this is going to change. 106 to change now. This is 357. Is the total length of the reinforcement divided by the spacing. Right, so the number is, we're dividing by 300 mm spacing. Let's see if that is, see the link, this is it here. Y1004 at 300. 300 is the spacing. That's what we were given in the drawing. Right, so divided by, that's why you see divided by 300 plus 1. That gives us that in particular information. So Y10 is 0.616 or 0.617. Who approximate. Right, divided by 1000. That gives us in tons. You must state it in tons because reinforcement is in ton in the BSMM4, not in length and not in kg. The slab reinforcement, we're not given the details, so factor must have been used. Right, so whatever the concrete is multiplied by whatever factor. What's the total concrete? So of course we're not squaring. So whatever the total concrete is, let me see here. Concrete to slab 16.3 by 8.94 by 0.2. Let's see. This is what this is. This will be 16.34.3 times 8.94 times 0.2. Okay, let me do it here. This is what it means. 16.94.3 jar by 8.94 excuse me, by 0.2. Right, so whatever I have here, I multiply by, let's say 80 kg. Let's say 80 kg. Right, 80 kg per cubic meter. Multiply by 80 kg per cubic meter. I get it in tons. I get it in excuse me. I get it in tons. That's 80 kg reinforcement, 80 kg per cubic meter. So the formwork, all right, we'll sum formwork to ground beam. We already calculate, we know the total length of the ground beam, which is 106.88. Right, and of course the formwork is to two sides. Let me quickly show us here. This this side and this side. Now of course if you see it here also, this side and this one side, and then the other side, this side, and then excuse me, the other side of it. All right, of course we know the effective depth of our beam, which is this 900, right? 900. The remaining part of it is going together, is going to connect with the slab. So this remaining part of it is exposed to connect with the slab. It has been 900 or 950. Let's see this drawing. Come here. Let's see. Formwork. 950. It will be 950, not 900, because you already cast your beam before the blinding, so you already know the depth, the depth of the beam, because the blinding also does not cover the beam. Bam, it is 950. So this is what we have here, right? So to sides of ground beam, of course, this of course, by the time you cast, if you want to cast, you need to put formwork right round. What do I mean here? Formwork for me to cast, and of course is a, excuse me, it's a linear meter item, because it is just 300 mm in depth. So these two sides of ground beam, 16.3, 8.94. Where did I do that? I did not put it though. Really? Am I sure? Let me see. It is here. 16.3 by 2, 8.94 by 2. I didn't put it that it is a linear meter item. All right. Then, of course, our damp-proof membrane. Damp-proof membrane comes here also. Remember I said by the time you fill, you compact, then you put your damp-proof membrane, and then your blinding comes, and then you place your reinforcement, connect them accordingly before excuse me, before you cast. So damp-proof membrane is length times breadth, 16.3, 8.94. Right, so that is all. So we've been able to treat all the items one after the other until the damp-proof membrane for this raft foundation. We have done the excavation, we have done the ground beam, we have done the reinforcement, we have done the concrete works, we have done the formwork, we have done everything for this particular excuse me, raft foundation. So this is basically how you measure a raft foundation. Right, now I hope this video helps you. Don't mind me, I have cold, so you can see I cough. I hope this video helps you in your professional career, in that your next job you are going to land, in your academics, knowing how to measure raft foundation. This is Chaka Contics. I'll see you in the next video. Thank you.